Welcome to True Projects. In this video, we are going to explain about the project that is Sunrise in the Desert, leveraging big data analytics for predictive solar energy production in Saudi Arabia. So before getting into the execution, first let us understand what is this project about. Saudi Arabia's energy use is increasing quickly because more people are living there and industries are growing fast. Until now, most of this demand has been met by burning fossil fuels like oil and gas. The issue with this is that it releases a lot of carbon dioxide, which harms the environment and also adds to the climate problems, that is, global climate problems. So, to tackle this challenge, the Saudi government is turning towards cleaner and renewable sources of energy, especially solar power. One major step in this direction is the King Abdullah City for Atomic Renewable Energy, a project that already plays an important role in supplying part of the country's energy needs through solar power instead of relying on fossil fuels. So, solar energy. Solar energy is a great alternative to traditional power sources, but predicting exactly how much energy it will produce is not easy. This is because solar power depends on the changing weather conditions like wind speed, temperature, humidity, and sunlight intensity, which can vary a lot from day to day. So, traditional forecasting methods have a hard time handling all this complex data and making accurate predictions. That's why there is a need for smarter approaches that can process large amount of environmental information quickly and give reliable forecasts. Being able to predict solar energy accurately is very important. It helps in planning how much energy to generate, keep the electricity grid stable, and support Saudi Arabia in moving towards cleaner, suitable, that is sustainable energy sources. So to overcome with all such issues, this project it proposes, that is it integrates a design to predict how much solar energy can be generated in Saudi Arabia. So to do this, it uses a combination of big data tools as well as machine learning models. So it can handle and learn from very large amount of environmental data. So it works by analyzing important weather and environmental factors like temperature, wind speed, humidity, and sunlight intensity, that is known as global horizontal irradiance, or we call it as GHI in short. So these factors directly affect how much energy the solar panels can produce. Using this approach, the system can make accurate predictions even when dealing with a huge data sets. And here, to make sure the predictions are accurate, the system first it cleans the data. So first it cleans and prepares the data. This includes filling in any missing information, bringing all the data into one similar scale, and selecting the most important factors that affect solar production. So, after the data is ready, machine learning models like linear regression and decision tree are trained using this data. The system then checks how well each model performs by measuring the difference between the actual and predicted energy using metrics called RMSE, MAE, MAPE, and R score. This helps in choosing the model that gives the most accurate forecast. So, besides just predicting the solar energy, the system also uses big data analytics and visualization to help understand how different environmental factors like temperature or sunlight intensity affect the energy. So, by combining these insights with the prediction models, the system becomes more powerful and reliable, and it can help with planning how much energy to produce, making better use of resources, and support Saudi Arabia's efforts to expand renewable energy in a smart and efficient way. And to further improve the performance of this project, here as an extension, we are incorporating multiple models. So, to improve the accuracy of solar energy predictions by using more advanced machine learning methods called ensemble models. First, we have applied random forest algorithm and carefully adjusted its settings, that is tuning hyperparameters, to make it learn better from the data, and this helps to reduce the predictions errors, especially lowering the RMSE, which measures the how far the predictions are from actual values. Next, we have also integrated other advanced algorithm called gradient boosting trees, also with the optimized settings. This further improved the accuracy of the forecast, giving even more reliable predictions of the solar energy production. And on top of that, Here we have developed a simple user-friendly interface using Flash framework, which allows users to enter, input data, and get solar energy predictions directly from the system. This makes the system more practical and interactive so users don't need to deal with complex coding or data processing. They can simply use the interface to get accurate forecasts easily. And to implement this project, here we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented this project. First, we have imported all the necessary Python libraries that will help in data processing, visualization, model building. Then comes initializing Spark session. So here we start an Apache Spark session, which allows us to handle and process large datasets efficiently. Coming to data acquisition. Here we download the solar energy dataset from an online source, and the dataset is then loaded into the Spark environment so it can be processed and analyzed. Coming to data pre-processing, any missing or incomplete data is cleaned and corrected. All features are normalized to bring them into a similar scale, making the model training more effective. And chi-square feature selection is used to pick out the most important factors that influence solar energy productions. And the clean and processed dataset is split into training data for the model and testing data to evaluate the model effectiveness. Then comes exploratory data analysis and visualization. So here we will be visualizing social power trends, that is solar power trends over different years and months to understand patterns. Frequency distributions for the global horizontal irradiance, that is GHI, are plotted to see how sunlight varies. And air temperature, wind speed, and other factors are analyzed to see their impact on social solar energy generation. A correlation heat map is generated to remove highly correlated features which could negatively affect the model. Then comes model training. So here, machine learning models are trained on the pre-processed data set to learn the relationship between environmental factors and solar energy production. Then advanced models like random forest and gradient boosting, that is GBT, gradient boosted tree, are used with the tuned parameters to improve prediction accuracy. Then all the models are evaluated using RMSE, R-score, and MAE. And in the front end, which is developed using Flask, users will be able to provide user input that will be pre-processed at the backend. It will be fed to the train model, and the train model will be predicting the solar power energy. So this is how we have implemented, and these are the algorithms used in this project. And to implement this project, basically we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, let's open the code folder that contains source code files. And these are the source code files of this project. In this folder, we have the dataset that is used. So this is the solar energy data. Let's open it. It's opening. Just wait for a while. And here we have the dataset open. So here we have attributes based on which we will be training the model for predicting the solar energy. Now close it. And this is the test data that we will be using in the front end. This is the static folder. This folder contains files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And this is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the Jupyter Notebook file, which contains code, that is, which contains a combination of code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have main.py file. This file contains the information related to front-end logic. It includes code written in Python and that handles server-side operations, such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here we have a Windows badge file. So instead of executing this project through command line interface, we have created this Windows badge file. And here we have database file, which is used to store the user information. So to execute this project, we need to double click on this run flash.bat file. So click on it and click on run. Here, this main file, that is main.py file, will be compiled, and this command will execute Python script, and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. So here main.py file has been compiled. Here you can see Spark session has been initialized. So this is the address where application has been hosted. So copy this local link provided by the Flask framework and paste it into any web browser. I have copied the link and I prefer Google Chrome. So I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So this is the web page of this project. And now let's click on new user register. So click on it. And here you need to create an account by filling all these details. I have already created account, so I'll directly log in. Click on login. So provide your username and the password. Now click on login. We have logged in successfully and redirected to this prediction page of this project. So we can click on start prediction, or we can click on solar power prediction here. So let's click on start prediction. And here you can see a choose file button. So here you can see a choose file button, right? You need to click on that for uploading the files to do the prediction of solar energy. So let's click on it and open the dataset folder. Select the test data, click on open. And here you can see file has been loaded. Now we need to click on generate prediction. So click on it. The given file will be pre-processed at the backend. It will be fed to the train model, and the train model will be giving us a prediction. So here you can see analysis has been completed, and here you can see solar energy prediction and analysis has been successfully completed. So these are the test values that we have given to the application for predicting the solar power. So here you can see multiple inputs we have given for every test case. So for this test case, the solar power that is predicted is 428.95 of kilowatts. Similarly, for this, we have 514, and for this one, we have 428.95, and for this, we have 344.54, and for this, we have 268.1. So accordingly, for all the test cases that we have given, we have the solar power prediction. So if you want, you can even print the results. Now let's check with the graphs. So let's click on data visualization. So here we have the graphs. First graph is the power generation distribution over the year graph. So here this blue represents 2023 and green represents 2024 and 2022 represents orange color. And here we have distribution and frequency of GHI value. This is the scatter plot, and this is the average wind speed against the GHI graph. Here we have average month-wise power generation graph, where on x-axis we have month and on y-axis we have generation. Here we have correlation matrix for all the features, which shows the correlation between independent features. And here we have RMSE error comparison graph, and here we have MAE error comparison graph. Now let's click on log out. So in this way, just by giving required inputs to the application will be accurately predicting the solar energy which is generated. So this project shows how solar energy in Saudi Arabia can be predicted more accurately, helping the country make better use of clean and renewable energy. By understanding how weather and environmental conditions affect power generation, we can plan energy use more efficiently, reduce reliance on traditional fuels, and move towards a greener, sustainable future. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.